and Corky you want to talk about. So welcome again. I'll let them take over. Gary, if you want to say something, or Corky, I don't know which one wants to go first.
Corky, you're first. Right?
Gary, go ahead.
No, you got it. You have the floor, Corky. Go ahead.
All right, buddy. All right. Well, as always, we're pushing membership. Everything in our association revolves around the number of people that are have memberships as well as participating online. So each and every one of us is an ambassador of the chapter, and we ask that you constantly invite your clients, your friends, anybody that you think might benefit from membership. To enhance that, we like to do events so that we can do meet and greets, and so that it's a little bit more hands-on, particularly as Omicron subsides a little bit. So we're going bowling. We are going to be going to Aztec Lanes. There will be an email going out. We want to talk a little bit about it tonight. I'd like to get it scheduled in the next 2 to 3 weeks, which is either, I believe, that Thursday the 28th or Thursday, March 3rd. And it will be an official CC event. Everybody will be paying for their own bowling. And we're looking for vendors who want to sponsor food and drink. So that's what we got going on. There's also an events committee. If you're interested in being part of that, please notify me, because in April, we're looking at going to Bernardo Winery, another meet and greet, another get out, have fun, enjoy ourselves, remembering all the time that we are an educational society. So before the meeting started, we were talking about MEC 1, MEC 2. Those are the 2 certifications that CSHE offers. ASHE, our parent organization, offers CHFM, which is Certified Healthcare Facilities Manager. But we are talking about MEC 1 and MEC 2. So again, please, the organization, our San Diego chapter, only thrives by your involvement. If you want to get involved, we'd be thrilled to have you. Thank you.
Thank you, Corky. I just wanted to add on to that. I was saying, I'm just like everybody else. We work hard. It's a long day. I want to study for school. All of my school days, I was always trying to get out of school. But, we're going to try to make it fun, interesting. We'll all get through it as a group. And that's how I feel about it. I'm really going to try to make a good effort in finding out more information on that and start moving towards setting up training groups and try to nail that one down and move forward. Gary?
So as Corky mentioned, we're pushing membership. If you guys can see the form, Beth, you can get that to them if they request it. Is that correct?
Yes, absolutely. And you can also sign up online pretty easily too. But if you have any issues, anybody can contact me anytime.
Thank you, Beth. Okay, so tonight's topic is water management plans. It's presented by Christy Thornton and John Martinelli with Forensic Analytical Consulting Services. And I know they're just ready to go, so you have the floor.
Thank you. So yeah, we wanted to just go over some of the common hurdles for an effective water management program. We know everyone's probably aware of the new standard and what it entails, but just some of the common hurdles that we've noticed and hopefully things that we can pass on to you all. So some of the objectives of this session are really to describe the importance of the multidisciplinary management team. We think that's really key to the success of your programs, that you need a variety of people involved, and to look at the importance of the water risk assessment, and in particular, the CDC's WICRA tool. It's a really useful tool if you haven't seen it or used it, and describe the importance of developing contingency plans and actions during your program design phase. You don't want to collect samples or get results and then have to look at what your controls are or what your plan will be. You want everything in place at the beginning. So we are talking about the Joint Commission standard, the EC 020502 that has come out, and that will be the main focus of this presentation. So what's new in this assessment, or in this standard? It applies to critical access hospitals and nursing care centres. It does reference the CMS memo. It pulls out the CDC toolkit and some CDC modules, and it also references ASHRAE 188. It does recommend using the CDC's WICRA tool in conjunction with some robust documentation and corrective actions as part of that plan. And this all came into effect on January 1, 2020. So the old standard really just said, manage your risk areas in water. It was kind of generic, not very specific. But this new standard is calling out 4 elements of performance, and it requires you to have a water management program for Legionella and other water-based pathogens that basically follows law and regulatory guidance. So that's the outline of it there. So the first element in that program really is the water management program, and having a team, having an individual or a team responsible for the oversight of the implementation of the program, including but not limited to development, management, and maintenance activities. So that water management team really is the core part of the success of your program. The CDC toolkit has this graphic attached, which really well represents what's required from your team and the variety of people that maybe can contribute. So you need someone with the ability to oversee the program, someone with the ability to identify and take corrective actions, someone to confirm the performance of your program. Probably want someone in facilities, someone in infection control, maybe outside vendors, someone with access to management or leadership, or the person with the money who can provide the resources needed to maintain an effective program. The second element of performance in the standard is basically your diagram. You want a diagram of all of your water systems, your treatment systems, your control measures, and all of the steps, including your end use points in your facility, including ice machines and all of that type of thing. It's a really robust diagram. And from that diagram, you then develop your water risk management plan and perform your risk assessment. So again, that first item is pointing out what your control measures are. Are you monitoring temperature? Are you implementing a flushing program? Are you monitoring your disinfectant? And then just doing that isn't good enough. We then need to look at what are your control measures? What is a good temperature? What is a good variation for your disinfectant? Your hazards, is temperature a hazard for you? Is there stagnation in some end use facilities? Do you have conditions for bacterial spread? Maybe you can work with your infection preventionists on ICU or NICU areas that maybe you're concerned about, really identifying where some of your hazards might be. Is there potential construction happening in the next 3 months in a wing of your facility that you need to be aware of that may affect the water sources? And again, this element calls out that CDC toolkit and the WICRA tool, so the Water Infection Control Risk Assessment. It's a really useful tool, and we'll go through that a little later in this presentation, but it gives you a good example of how to perform a qualitative risk assessment related to water. And that last point down there, that you need your monitoring protocols as well. So hospitals really should consider incorporating water monitoring within your water management program, whether that's temperature, residual disinfectant, pH, up to you to decide what your parameters are going to be and what your control measures should be, what your limits will be for your facility. And you really want to be specific about where your locations, where you're sampling from, what is the purpose of your sampling? Are you doing near and distal samples for just disinfectant or pH? Just a really well-structured program will help you maintain this the best. The third element in the standard is basically based on documentation. If you didn't document it, it didn't happen. If you didn't write it down, it didn't happen. You want to know how your monitoring is documented. Do you have a work order system? What's your internal system that will document all of these processes? What are your acceptable limits and target ranges for your disinfectant or your pH? What do you do if they're out of range? What is your corrective action? Not only what is the corrective action, but how is it documented and saved as part of this program so that you can see what you did to respond to an out of parameter reading. Where are you going to keep all of this documentation? Is it a folder somewhere? Is it on someone's desk? Is it an online? Just where are you going to store it? How can people get access to the documentation in the program? And also, how is it distributed? Are you going to have a once a month water management team meeting where you distribute minutes for a summary of results over the last month? Or is it a quarterly meeting? Just a really well-structured program. How are you going to document everything? Where are you going to keep your records? And how are you going to keep your team involved?
Can I ask a question?
Yes.
So that I don't know what anybody else knows, but I'm just gonna, like, they're not, no questions are dumb questions. Anyhow,
Not at all.
but what does this all mean? What are we talking about? Limits and testings, and what are we testing, and why are we testing? And are we talking about out of the tap? Or are we just talking about towers or chillers or everything?
That's a great question, James. We'll talk a little bit more about that in a few slides. And what you're going to hear is, here's the good news and the bad news. The answers to all those questions come from the water management team. You get to decide. Unfortunately, with that becomes responsibility and risk. So you've got to make good decisions when you do decide those things.
So having your water management team, so I did hear how far you can go with it and what you're going to do. So, and you were talking about having meetings and all this. I'm starting to ramble, sorry, but you guys decide on how far you take your actions, I take it, with water sampling and whatnot.
Exactly. But you just want to have it documented. Whatever you have decided as a team, if the best outcome for you and your facility is, once a year meeting, I don't know if that's effective, but if that's what you've decided is the best, you've got really robust controls in place, you're regularly looking at things, and once a year is fine, as long as it's documented. That's the key really to how this program will work. And it's an evolving, continuous improvement type of program and plan. So it's not going to be perfect the first time. It's going to grow as you learn more about, water sampling, if that becomes part of your criteria, or different areas in your hospital. You get a different member, maybe your program plan suddenly has someone from infection control and they offer something that you weren't aware of before. It's always evolving what you're looking at doing for your facility.
Thank you. I'll be quiet now.
No, that's okay. It's great. So yeah, that fourth element again is that your team or the individual responsible for the water management program, that you're reviewing the program at least annually, or if any significant changes occur, if there's changes to your water system, if you've put in a new wing or there's a new building and something's changed with your water system, you then review it again. Some points to note in this one, again, are that it calls out the Joint Commission and the CMS that they don't require culturing for Legionella or waterborne pathogens, but testing protocols are at the discretion of the hospital unless required by law or regulation. But the thing with that little note there is then the second note we have, which refers to the ASHRAE standards, in particular the Legionellosis risk management for building water systems. So if you're not sampling for Legionella or for waterborne pathogens, if you've decided as a hospital, as a facility, that you're well covered and you've got great controls or whatever the case may be, you need to document it, because although it's recommendations aren't necessarily required, if someone was to come in and audit you, you really need to be prepared to explain hopefully with some evidence-based monitoring data or information from your water management team as a whole that shows why you chose not to collect samples or not to do something that's called out in this standard. Again, yep, that ASHRAE documentation, if you haven't seen it, it's accessible online, and it's the Legionellosis risk management for building water systems. So we then wanted to just go over some of the elements of a 188 plan. I know this was covered during a chapter meeting late last year, so we don't want to go too in depth in all of those, mainly just focus on a few elements that we think maybe might have a bit of a hurdle, or you'll get the most impact from if you spend the most amount of time on those. And the first one is that program team. Again, we really think being able to accumulate a multidisciplinary team is really the key to the success of a program like this. It's designed to be continuously improving. There'll be new members that come in and that can contribute more. And you'll probably learn a lot about this over the next year as you implement your own programs. So that CDC guidance, again, pulls out some of the ideas of what your team members should be able to bring to the table. You want someone with access to the money, someone with really good familiarity of your water systems, and then maybe some infection control or EHS or safety professionals. Give you an idea here of some of the members, lab personnel. If you have a big construction project going on, maybe you might have some of your construction administrators, architects, design engineers, EH&S specialists, some of your directors in your specialized areas, maybe someone from your NICU or your ICU can be involved. Just really getting a good variety of people that can have continual involvement in this water management program, and the development of the program will be beneficial for you. Again, just to highlight the team roles a little more. Leadership, you need someone with access to the money. If you can't fund a program like this, or the corrective actions that might come out of a program like this, you're basically set up for failure. You need those people like yourselves that are the most knowledgeable about the water systems. And then you need the people that can perform the sampling, whether that's internal, you've trained yourselves, or external vendors, treatment contractors, external IHs, and verification. So you might have members of your management team or auditors that come in and verify that the program is working and that you're following it effectively. And the next aspect of this that we really wanted to pull out again is that analysis of building water systems, which is the risk assessment. The risk assessment really drives all of the actions that you are going to take. It helps you look at your control locations, maybe your control measure ranges, helps you establish your contingency plans and your response actions, where you may need validation testing, why you need it in those areas. Until recently, the risk assessment process wasn't very well defined, and it was sort of up to each facility if you did one and how you did it. But the WICRA tool, the CDC WICRA tool, has really helped establish some clear, concise steps on how to perform that risk assessment. It's quite user-friendly. I don't know if any of you have used it or seen it yet, but it does result in what we have considered to be a fairly good semi-quantitative outcome. And it does rely on team participation. By no means is this expected that you can go through your hospital and complete this on your own. You will need assistance from members of your team, and that's how you'll get the best outcome from this risk assessment. Again, it's a CDC toolkit. It's located online, clearly follows 8 steps for your risk assessment, explains them quite succinctly, and it does have some other tools on there that are useful. Some checklists and toolkits that you can also access when you're looking around your facility. So this is a bit of an example of what happens if you're in that CDC toolkit. It basically points out some of the water sources that you may see: sinks, toilets, humidifiers, endoscopes, ice machines, all the way down to things that might be in your surgical wards. oral care, anything basically that is a water source, you will identify that. You'll then move into the mode of transmission. So, are they bathing or showering, or is it an indirect contact? Is it inhalation of aerosols, maybe from a finer water spray? Is it aspiration of the water or the droplets? Again, this is all set out in this WICRA tool. The next two are definitely open to interpretation. Obviously, it's a qualitative assessment, so you are putting your own consensus on whether you think patient susceptibility is highest, high, moderate, or low. Your opinion may be different to somebody else's, which is why it's beneficial to do these in groups of 2 or 3, get a range of opinions and come to kind of a consensus on, is it the highest patient susceptibility? Is it high? What do people agree on? Same for patient exposure. It does give you some indicators. So high is high frequency and duration, moderate, combination of high and low frequency. But again, your opinion of what high and moderate is maybe different to someone else. So the more people that are involved in the risk assessment, the more thoroughly you'll understand the area that you're looking at, what the hazards are, and maybe what the patient susceptibility and exposure may be. And the last item on that toolkit is your current preparedness. Again, it gives you some indicators. Are you poorly prepared? Are there limited policies and procedures in place? You don't have many mitigation strategies, all the way up to good. You've got some robust policies and strategies. Everyone knows what the best practice is, and you have some great mitigation strategies. Using those as a guide, you are then able to fill out the risk assessment tool. We've just given an example here, a fictitious example. So hospital A, we've got an ICU. Again, you can see some of the members of a water management team that even the CDC is calling out. So in this instance, it was an infection preventionist and a facilities engineer that performed this risk assessment together. You've got 2 varying backgrounds that are coming together to both provide their input on what the risk may be. In this instance, they're looking at sinks with an aerator, no splash guard in a prep room. They're saying that this is the highest patient susceptibility. The patient exposure is moderate in that instance. Their current preparedness, they're not very prepared in this room for this fixture. So it's got quite of a high total risk score. And from that, you can then categorize what are your high risks, what are your low risks, maybe what are areas that you need to focus on initially in the program. There's also room for comments, so you can add at the time simple corrections. Maybe your facilities, you guys can come up with something, or an infection preventionist might come up with something else. Installing splash guards, putting a lid on a toilet in a patient room. Some of them may be really simple controls that you can do fairly quickly, which will reduce your risk score and take some of the pressure off you in the long run. All right, so the next aspect on that element of the 188 plan that we wanted to call out was control measures, and I'm going to hand over to John Martinelli here, and he'll hopefully give you some more information.
Thank you, Christy. Go ahead and hit the next slide. So one of the things that, in answer to your question, James, I heard someone call you Jimmy, but I don't know you well enough yet, so I'm going to call you James because that's what's on the screen. We look at the risk assessment, and let's say we find that one of our areas of concern is temperatures at a hand washing sink in a NICU, because it's in close proximity to where the kids are, and we are having trouble getting the temperature in the range that we need it. So first thing is setting the control ranges. We know what we want them to be at. Ideally, we'd have them at 120 degrees. The challenge with that is we've got some other legislation that prevents us from being above 120 degrees. So this is where it really becomes a delicate balance. We want every fixture to be as close to 120 degrees as we can. But if we've got the first fixture that's near to the riser and we get it at 118 degrees, how hot can we get the farthest fixture from that site, right? And we see a lot of literature that says 105 to 120. You know, as long as we can keep it above 105, we're not going to kill anything at that temperature, but it slows the potential for growth. That's really the key here. And understanding how the building can function is really important. So when we're doing that risk assessment, we first find the risk, and then we're going to set those control ranges based on that risk. And so there are a few guideline documents that are out there. And one of the documents that was mentioned in the Environment of Care Standard was ASHRAE Guideline 12220. That's one of them. That's also referenced on the CDC site. You can see a link here to the site, but you can just go type in CDC Legionella and you're going to find this very easily. There's a few other guidelines that are available. There's the AIHA guidelines that's put out by industrial hygienists, recognition, evaluation, and control of Legionella in building water systems. There's also an AWT position statement and guidance from 2019. So you look back to your team and who you've got on your team. Who on your team is going to be familiar with these references, because these give you the guidance for setting those ranges. And it's not just ranges for temperature. That's the easy one. It also is ranges for chemistry, and it depends on the chemistry you're talking about, right? If we're talking about monochloramine, the concentrations are different than free chlorine. So these references are nice. You can always buy these references and develop your own in-house expertise, but it may be easier for your team to engage someone else who has this knowledge.
Hey, John, can I ask you a technical question on there?
Sure.
So one of the challenges that you have has to do with the temperature, because once you get like just below 100, you're in incubation temperature territory, right? So it is, and when you're putting in different gauges throughout, you have a lot of enthalpy, a lot of heat loss going on. So in areas where you can't meet that 105 for whatever reason that is, and I didn't see anything on here, are they still allowing the point of use bacteria filters, like their autoclavable point of use filters that they put on there? I know we did a lot for hospitals in the past, but I haven't heard much of that recently.
That's a really good question. And the truth is, point of use filters are used quite frequently in response to a problem, right? They're not used a lot of times proactively. And I'm not saying they're not, I don't see it commonly used to address temperature problems, but they are, you can certainly make that decision. That doesn't come without a cost. You have to maintain them. You have to put them on and off safely. And there's a cost associated with it, but it's an excellent question. And the example you bring up of difficult temperatures is a common problem that we face. And that's when you go back and you start looking at your response actions. If we've got a high risk area and we see something that goes out of range, or we can't keep it out of range, maybe we implement a response action where we hyperheat those fixtures every Thursday or something like that, right? Which I'm making stuff up as I go here. We have to look at it, what's feasible and what works. And so we can look at, if we've got a certain amount of bacterial load in that fixture, does hyperheating it on a regular schedule work to keep that bacteria managed, right? So you've got to find that sweet spot where you're doing the right kind of testing at the right locations to determine if your response actions are managing the problem that you've got with your system. The other thing you can do is look at a capital improvement where you put thermal mixing valves on the floor so you can increase the heat getting to that floor and maybe make it a little bit more stable. We see that a lot in high rises where you start getting up to the 6th floor and you get to the distal end of the 6th floor, and the temperature difference at that fixture is significantly different than near end on the 1st floor. And if you try to get it hot at the distal end up high, you're going to burn somebody on the 1st floor. So if you can get the capital projects to put in a thermal mixing valve down the road, now you can start increasing that circulating temperature.
Last question having to do with bacteria, because that's the biggest concern. So in some of our new dialysis installations that we're doing, we're putting in ozone. Of course, these are greenfield or maybe even a brownfield project, but I haven't really seen a lot of that, because you really can't, it's really too hard to monitor. It's easy to inject, but how do you actually balance that and make sure no one's using the water while you're doing that? Late night hospitals, et cetera. Have you seen, you or Christy, seen anything like that? Are we getting any momentum or movement on that technology?
It is becoming more common that people are injecting ozone in various systems. And pointed out some of the difficulties. It's a very difficult, very dynamic process that changes rapidly once it hits the systems. And it has a lot to do with the amount of biological that it's coming in contact with. If you've got a lot of biofilm, you're going to see the ozone deplete rapidly. So that it may
Temperature
not,
also affects that a lot too. The higher you go, the more rapid it dissipates.
well, and this is really complicated and it's high-end stuff you're talking about here. But once we start getting into those treatment modes, we've got other issues to worry about besides just getting the chemistry right. We can have disinfection byproducts that are resulted that may be carcinogen or may be regulated, so we can't just dispose of them down the drain. And getting concentrations right. And we have seen circumstances where we go in to get an aggressive treatment and we actually see the numbers go up for a short period of time before they start coming back down because we start breaking the biofilms loose, and it's really a difficult process. And you mentioned another thing is protecting people when you do it. Even if it's just hyperheating or hyperchlorinating, we've got to do it in a way that we're not exposing people during that process. So it's usually a major event where we're putting signage up everywhere and have a lot of people stationed at various fixtures. And we do it late at night when we have the least impact to patients and things like that. So these are all really good questions. Next slide, Christy.
Yeah.
So here's an example, just setting the control range for low use fixtures. Let's say we've got an EVS closet or a shell space where we've got patient rooms that are not in use yet. Those are essentially potentially dead legs. So how do we do it? We've got potential stagnant conditions. We can use flushing to reduce the stagnancy and flush to temperature stabilization on some sort of schedule, right? And then we could use point of use filtration, as you just mentioned, but how frequently do we do it? Who's the responsible party and how do we document it? And what is our corrective action to take? Do we need additional training? Is this something EVS is going to do, or is this something plant ops is going to do? And then getting to that sweet spot where I've got 1 part per million chlorine coming in from the municipality, but I notice in the EVS closet, we have very low chlorine and we flush it on Thursday night. We come in, we measure it on Saturday and we see that it's now getting up about 0.8. Are we flushing too long? Are we flushing not long enough? So this can be a process that's ongoing. And then how do we monitor it? Do we monitor for scale and corrosion, temperature control, low or no disinfectant? Do we monitor for bacteria? Again, what's the frequency? Who's responsible? How do you document it? And what are we going to do if the results we get we don't like? You're going to hear again, it's really important that you make these decisions before you start collecting the data. Next slide, please. So the validation and contingency plans. There's 2 terms that come up frequently, verification and validation. Verification is verifying you have an effective program. That's kind of a paper review. Are we meeting regularly? Is the whole system itself improving? This is a continuous improvement process. And if we're auditing to show that we're continuously improving quarter over quarter, that's verification. Validation is checking the control points. Go ahead and advance the slide. This may be the most complex part of your plan. How are you going to do it? Who's going to do it? When and where to test? This all comes from the risk assessment. We've seen a lot where we'll do a certain type of fixture on every floor, every testing evolution. We're going to test a shower head on every floor every time we come out, but not necessarily the same shower head every time. However, there may be one sink that we test every time because it's in the NICU or it's in the ICU where we have a high risk population. So, and how are we going to do it? Are we going to test chemistry, temperature? Those are listed in the environment of care standard. So you probably need to do that. But even that, where are you going to test temperature? Are you going to test it down in the basement at the boiler? Or are you going to test it at the distal fixtures? If so, what's your thermographic method? Are you using a NIST traceable thermometer? Are you looking at how hot it gets and how long it takes to get that hot? Who's going to do it? How are you going to document it? Are you going to do microbiology? And that's not just testing for Legionella. It might be Pseudomonas or heterotrophic plate count or testing for other odd things if you've got reason to be concerned, like Burkholderia or Stenotrophomonas. You can see those listed there, are non-tuberculous mycobacteria. And those a lot of times are driven by case responses, not general system parameters. Who's going to interpret those results and have the team agree on what the acceptable ranges are? And again, you may rotate fixtures or pick the same fixture every time, depending on your program needs. And different organisms may require different testing methods. Next slide, Christy.
Oh, does everything start with your risk assessment?
I really love that you answered that question. Yes,
Because I've heard it come up a few times.
it really does drive this. If you go back to that risk assessment tool, you will maybe recognize that there were a couple of areas that really jumped out. They were in the 20s and 30s. And you're going to look at that and you go, okay, if we're going to start doing validation, we're probably going to pay really close attention to those areas because they present significant risk to us. If I've got an area that's got a 9 or a 5, maybe I don't include that every time. But if I've got a lot of 9s and 5s and it's some low-hanging fruit that I can fix, maybe I will pay attention to it. So, and remember that table that Christy showed a little bit earlier, what's the program element, who are the people that are needed? This is the validation element of it. It's the people that have the ability to monitor and document performance of the program, and it includes interpretation of the data. Next slide. And now monitoring and corrective actions, the contingency plans. Go ahead and advance. What do we do? What this is what do we do if we've got something that's not in our optimal range? If it's a temperature that's a low risk area like a EVS closet, our response is going to be a little bit different than if we've got an area that's gone right into the optimum growth range. It's a high risk population and it's been out of range for 3 months. So that's what we look at. And it depends on the parameter you're testing, the location, the severity, and the risk. What are we going to do if it's out of range? Are we going to flush? Are we going to heat it? Are we going to treat it? Are we going to replace something like a fixture? Are we going to add point of use filtration? Or is it something else altogether? Are we going to go in and physically disinfect the sink? And by the way, it's not just the faucets. We have seen more evidence that the sink drains are becoming a risk factor. If we've got splash from a hand washing sink, we can get some of the bacteria that's in the drain to splash onto the counters nearby. Contingency plans should be determined in planning and development, not after a failure event. During the failure event, it gets emotional, it gets urgent, and we have a hard time picking who's available to do what. What's really important is we need to know if we're going to use heat, how hot can we get it, and how can we do it safely? We can superheat to 150 degrees and circulate that through the circulating system, and then start at the distal end and start flushing the faucets our way back. How long do we flush each faucet till it gets to 150 degrees for 2 minutes, 4 minutes? All that depends on the conditions that we've determined. If we've got significant biofilm or significant bacterial counts, we're probably going to go longer. And if we're going to use chemistry, it's the same thing. What's the concentration and how long is our dwell time? It's like anything else. We need contact with the organism, we need concentration, and we need time. And how do we protect others during our response actions? Like I said, this is almost like an incident command process, right? Where we're going to go in and we're going to impact that we've got significant problems with bacterial growth and an outbreak of responses. Now we're going to start doing some pretty dynamic things with the system. It requires a lot of coordination, not quite incident command, but it gets towards that level. We got to define who does what and when they do it. Have your emergency response agreements in place with your vendors. If you've got point of use filters, you need to know what kind of filter you need for your shower heads or for your hand washing sinks. You don't want to start having that conversation and have them telling you, well, this is what we've got for you. You want to know already not only what they have, but what's going to work for you and how many you need and how quickly they can get them to you. Remember, emotions are running high during these events, and you want your vendor support to be committed in advance. Chemical treatment options vary. If it must be used, it's got to be compatible with your systems that are in place. And there's a lot of debate over hyperchlorination. That's something that has historically been very popular. Most facilities have dealt, not all now, it's changing, but chlorine has been very commonly used as a general disinfectant from the municipalities. And we like to throw a lot of chlorine at stuff but we're finding, chlorine is really good at killing the bacteria that's floating around in the water, but it's not as effective at penetrating into the biofilms where those things are growing. In addition to that, it kills everything that's floating around, and most of what's floating around is probably harmless bacteria that's competing for the nutrient in the environment. So some of that bacteria is actually helping to control. And when we go in and we hyperchlorinate, we may create an unfair environment for some of the other bacteria that remain behind. Additionally, non-tuberculous mycobacteria are barely touched at all by chlorine. So if we go in and we chlorinate, we may create an unfavorable advantage for something else that's also a risk factor, something we're concerned about in unintended consequences. Again, different organisms require different response actions. Go ahead to the next slide. Scott asked, will you get a copy of this presentation? I believe it's going to be recorded and distributed by Sishi. And we can provide copies of it as well. So remember, this is the overall 188 plan. This is something you saw Precept and Nephros talked about it in September. You'll see it again if you go to the San Francisco chapter next week. These are the elements. Go ahead and advance this slide. Challenges can exist at every stage of this program. However, the most significant challenges are those that we've listed. Having an effective team is really important. You've got to have good expertise and you've got to have authority to take action. Getting a comprehensive diagram together, that's kind of a one-time deal, right? Once it's done, unless you make major changes to your system. But a lot of this stuff is ongoing. So that 188 system allows for a team to set the standards and practices, but with that freedom and flexibility comes responsibility and risk. So you've got to have the right people making those decisions. And as Christy said, if you do that as a team, you're going to have a lot more confidence and it's much more supportable should you be audited. Look, we brought in the right people. We had a conversation. We arrived at these ranges using these resources. So this is why we feel we have confidence in our plan.
This is my risk assessment.
Yes.
So again, there is no requirement to sample for Legionella, but I will tell you, if you look at certain documents and certain opinions, if you want to know that it's not there, the only way to tell that is to test for it. The challenges are, if you test for it, you're probably going to find it. And there's, in general, 3 conditions that exist when we collect samples. We didn't find any, so we're feeling pretty good. We found a whole bunch, so we know we got to do something. It's the one in the middle that causes the problem. We got some hits, but not all hits. We got some colony forming units that were in that close to 10 range. What do we do about that? Those are the conversations your team needs to have before you get the data. Not only is there no requirement sampling for Legionella, but there's no real standard that we get to apply to. There's a lot of things that are talked out there about if for general system performance, if you've got less than 30% of your samples testing positive, you seem to have a healthy system. But that doesn't mean if one of those samples comes up with a very high colony count and it's in a high risk area, that you can ignore it because you've got less than 30, right? So it's really a tricky process. There is a requirement to test and prove the effectiveness of your controls though. So that's where you go back to say, what is it that how do we prove that our controls are effective? And again, it's a continuous improvement process. What you want to show is that you have a strong team, an effective program by following these guidance tools and improving conditions over time and documenting that you have those conditions improving over time. Prioritize, act, and document. Make those significant risks your high priorities. If you've got low-hanging fruit that's easy to correct and you can do with existing resources, go ahead and do that. That counts as improvement. And you can look for those capital planning things. If we've got some big ticket items that we need to do, let's get them into the capital improvement, start talking to the construction people so that we can get those as part of our overall system improvement. Go ahead and advance the slide.
I think that's all we had.
That's what we have. It's time for questions, and I'm getting ready to answer a question in the type here. So Angel was asking me about the San Francisco presentation. Any questions?
You're answering one.
Yeah, but Angel asked if there was, if he should contact me or Madeline for the San Francisco chapter presentation. Madeline is the Christie. She's on that. We're doing it together. Only this time it's Madeline instead of Christie. So she's kind of taking the lead on the contact. Thank you, Felipe.
So yeah, that's a lot of information.
So I did-
Big thing that I heard was, well, there's a lot of information, but the risk assessment, having the right team and a plan. That's, I'm not sure how many people already have that. I know we do. I would imagine most people are on board, but it's an interesting topic because there's just so much.
It is. What we have found is it's very complicated, and quite frequently what happens is lands on plant ops desk or the facility manager's desk, and they say, here, take care of this for us. And it's overwhelming because you just don't have the resources, and a lot of times you don't have the internal expertise to cover all these things. But in response to your thoughts, yes, it starts with a good team and a good risk assessment, and then coming up with the right response actions if you find things that aren't working where you need them to work.
I had a question about, you were mentioning Legionella about cooling towers. So to address what Gary said, though, I mean, really being able to identify all the different risk areas is a challenge. You know, you really have to be aware of temperature, risk points, you know, distances, dead legs, you know, chlorine, testing, places that people aren't using faucets very often. There's so much to it. So on my question on there regarding the cooling towers. So I know with Legionella is primarily airborne, and I haven't seen a good program out there. We've done a couple for SeaWorld, but for actually the cooling towers and spraying those down, you know, with like ozone or something, just to try to kill the outside. You're talking about competing bacteria on there. Have you seen that about, you know, with the actual towers itself, where they've been doing like ozone sprayed ozone sanitization? Has that been effective or not? I'm not sure if that's for you, John or Christy, if you guys have dealt with that or not.
I've seen some studies in the past when we were using chemical treatment for water, for cooling towers, which is very common. And what we saw was a decrease in total bacteria, but increase in non-tuberculous mycobacteria avium specifically, which is related to bird feces. So it does present some challenges, but it goes back to the risk. If it's limited to the cooling tower and it's not getting into your air handler or exposing people, then the risk isn't the same, right?
It's a different area of risk, like you were mentioning. I'm not talking about inside, because outside you're walking by the towers. You're right. You've got the bacteria. You have things that are blowing. There's a lot of food in there, and the actual air transference in there is very high, as we know. So, you know, when you can actually put, I'm just going back to ozone because that's the one I'm the most familiar with, is actually doing the outside of the tower itself by having some type of maintenance on there, because that would be one area where you don't even know where you get the Legionella, but cooling towers are one of the biggest culprits on the planet.
Yeah, they're associated with outbreaks, community outbreaks fairly regularly. The state of New York has regulated cooling towers for that reason. In cooling towers, a lot of times we see facilities, they have an outsourced resource that is managing it for them, managing the chemistry and doing the validation testing to prove that chemistry is effective. That's a lot of times you can rely on their expertise.
But that's the water, not the surface, the outside surface. That's kind of what I was referring to. It is doing the outside surface. That's where you normally get the outbreak on there, not just, you know, you're mentioning from the birds sitting outside on the towers, right, taking a bath, versus the inside where you may have a good chemical. Anyways, I haven't seen much of it out here in California. I know we've done some in New York and some back east where we have the the trailers where we come with an ozone, just kind of wash the outside of it down just to, try to keep it under a good maintenance program.
I heard you say something about the drains. That's gonna be a nightmare. That's gonna be hard to take care of the drains in my mind. What have you seen with that?
A couple of different things. One, it comes down to risk, right? And what are we using those things for? If we're not splashing, then we're okay. We're seeing a lot of places that are moving to offset faucets so it doesn't splash directly into the drain. And it's not something that we worry about in every location. It's where we've got higher risk populations, especially if we're talking about something that's not an inhalation risk. It's something that's going to transmit on a surface like Pseudomonas or Burkholderia. So it comes down to what's your risk there. You can certainly spend this is where it gets a little bit tricky. We can come up with a lot of solutions to solving all of these problems. But at some point, you've got to look at what your resources are and what your bang for your buck is. We're not going to send a lot of people around to start cleaning drains. That's not where your highest risk is. If you find that you've got a problem and it's connected to the drain, then you come up with a situation. You like to be proactive and prevent it. Get people to be smart, avoid splash, clean the areas around the sink. If they see splash that's occurring on those adjacent spaces, that they routinely clean those splash areas, things like that.
Awesome, thank you. Anybody else have questions?
Hey, Jimmy and everyone. This is Ben. I work for Mr. Perillo at Sharp Coronado Hospital. And I remember when this water management program, we were told that it was going to be a real thing in 2022. So I started taking pictures of my ice machines and replacing all the tubes. So yeah, that's the reason why, because we don't want to get a bad test, and that's all. So it's good to see you guys have a really good presentation. It's a good eye opener.
Yeah, and it sounds like you guys are doing exactly what we would anticipate, that you've got a big team of an array of experiences all contributing to this water management plan. It's a really big undertaking, and it's too much for one or two people to do on their own. You need a team involved, and you need that team to stay involved for the duration, regularly getting updates and providing input, not just doing that initial risk assessment and then not contributing after that, if possible.
This is Mark Kennedy. I have one question. Do the CDC guidelines or the 188, wherever, are there good policies and procedures that can be used in those documents, or is there a best practice set of policies and procedures?
Good question. There are some general guidance in the CDC site, the toolkit. They've got some guidance on response actions and ranges, but it's not a very means and methods process. It really can't be, because it isn't one size fits all. If you've got ambulatory surgery center that doesn't have any showers, it's very different than if you've got a long-term care facility. So it really, we can get into some of those documents, provide you some good. The AIHA guidelines have a lot of discussion in there about how best to test for parameters. And ASHRAE 188 does have a lot of detail in there about how to operate cooling towers and potable water systems.
John, I have a question. This is Gary. Ben brought up a ice machine, so I'm going to run with that. What have you seen with ice machines? We have a very robust preventative maintenance system to clean and maintain or sanitize our ice machines. But in particular, the drain pans, have you seen a lot of issues with drain pans? We're flushing our drain pans with warm water weekly to make sure we have good readings whenever we have them sampled.
Again, good question, Gary. Ice machines are kind of a challenge as well. You've got to follow the manufacturer's recommendations for cleaning and disinfection. We see a lot of people putting in carbon-based filters for flavor enhancement or to remove odor and manage taste. Those can actually become a source of bacterial growth. And yes, the drain pans themselves are a bit of a challenge because these things are really aggressive heat exchangers. To get that water to become ice, they've got to pull all that heat out. It's got to go somewhere, and it usually goes inside the box somewhere. And if you've got any standing water at all, you're probably going to bring it up to growth temperature. Now, having it be a growth temperature only becomes a risk if that has a potential to cross-contaminate something else, right?
Mhm.
So you have to look at it and say, is there potential for cross-contamination from the condensate pan or the drain pan to the source water, the ice that's coming out of the machine. And you've got to look at the way, and we're seeing, again, when we talk about capital improvements, the industry is self-correcting. Follett and others, they're coming up with ways that make their ice less of a risk to patients. It doesn't come without an expense, though. We're getting some pretty smart ice machines out there, but we got to switch them over. We got to train people how to maintain them. All of that has to happen.
All right, thank you, John.
All right, well, those were good questions. Thank you, Ben. Thank you, Gary. Anybody else have anything on this topic? I know, keep throwing things out. We can keep going on and on, but I know Gary would like to go home. So are there any last words? I mean, I would like to say thank you to John and Christy, and always, of course, to Beth and Sishi and my co-partners here, Gary and Corky. Gary, Corky, you guys have anything else to add?
Corky, go first.
I want to reiterate around the bowling night. We're going to be moving on that quickly. I know Elise from Patcraft is on the call, as is my deputy Andres. I want to acknowledge them for all the hard work they do. And Elise has also put together a lunch next week for the events committee, so we can up the rest of the year. But again, focusing on bowling, Sishi has been phenomenal for my career. I joined in 2007, so I've been around for a long time. But if you're a vendor, a great way to meet and interact with engineers and directors and managers is to go to our events. And if you are a director, a manager, or a vendor, it's a great way to learn to meet. This is available to you all the time. It's the camaraderie and the support that we offer that makes us so vital. So each and every manager, director, and engineer is out there facing whatever the problem is. Likely, one of these great guys, Jimmy or Gary, have faced it. So come out, get involved. COVID's been a drag. There's no doubt about it. We'll be as safe as we can. We'll be practicing social distancing the best that we can, but we're going to have a wonderful time. So if you got any questions, let me know. Give me a call tomorrow.
Thanks, Clark.
I'd like to thank Christy and John again for your presentation. Great presentation. Thank you so much. Beth, Jimmy, Corky, thanks for the teamwork putting all this together. I'd like to announce that on March 10th will be our next San Diego CSU meeting. It will be with Bill Summers from Anchor Med. And his presentation will be benefits of using fabrication and during HC construction. So we hope that you will join us again for our next meeting at 6 o'clock. That's all I have. Thanks.
I hope to
Jim.
see everybody at bowling. That's gonna be
Yeah.
awesome.
That'll be fun.
All right, if anybody doesn't have anything else, I would like to end our meeting and hopefully we'll see everybody at bowling next.
I'll see you
Thanks,
there.
everyone. Great presentation.
Thank you.
Thank you. Take care, all.
Truly, truly.